data. The first thing, if you look at page 264, is they give you a pictograph. You really don't. You can jot some of this stuff down, but most of it you just kind of get by looking at it there. When you have a pictograph, which means they show, they represent data with pictures, just to make it maybe a little bit more interesting. What is, as with all graphs, the first thing you always want to look at? First thing you always look at is, Wade?
What everything equals.
Well, the title. Did you say the title? Yes. For example, that graph there, it talks about what? U.S. car and truck production. Then after that, Wade, you look at what?
What everything equals.
Yeah, what does each little picture of a car stand for? Because obviously Michigan makes more than 3 cars. All right. Each car there stood for how many? A million. A million. So for Michigan, how many cars would they make?
3 million.
Yeah, 3 cars, which is 3 million, and so on and so on and so on. I'm not going to spend a lot of time on pictographs there. You know, you can cut cars in half, and if it was a half a car, it would stand for 500,000. The next thing they talk about is circle graphs. We've done that. Did we do that before?
Yeah.
Which also are called pie graphs. Why wouldn't you use a circle graph for the one above that when it talked about car production? Why wouldn't you use a circle graph to go from Michigan, Ohio, Kentucky, Missouri? Well, I guess you could. I guess I would. You could use that. Or when do you use pie graphs or circle graphs? Faith? Well, yeah. Well, when you're cutting, you need the circle has to stand for the whole thing. When you're cutting something, a whole thing into pieces. I didn't see where it said other on there. Since it has other, that means they group all states into one other thing there. You know, they said Michigan. How would I figure out how big of a pie piece to make each thing? Let's say I'm talking about those cars. Let's do it again. Michigan was what? Michigan was 3 million. What was the other one?
Ohio.
Ohio was
2 million.
2 million. Kentucky?
1 million.
1 million. Was there another?
Missouri.
Missouri was
1 million.
1 million.
And then other states.
And then other
5 million.
is 5 million. If since this is all, let's say this would be all the cars produced in the U.S., so I could use a circle to show that, how would I figure out how big of a piece Michigan would get? Or how big of a piece would I do for Kentucky or Ohio? Well, fractions, ladies and gentlemen, are your friends. You would have to know how many total cars are represented here. How many total are there? If you add all these numbers up together, 5, 6, 7, 8, 9, 10.
12 million.
Yeah, there are 12. This whole circle stands for 12 million. Okay. If Michigan has 3 million of the 12 million, doing a little math here, we could get rid of all those ending zeros because they'd all cross off. What fraction of the circle should Michigan have? If you reduce 3 over 12, Wade Davis?
1/4.
Right, so you can cut this thing into 1/4, and this would be Michigan. And this little pie piece, in math we don't call them necessarily pie pieces, we call them sectors. What sector does Michigan get? Michigan gets 1/4. How big would Ohio get? Ohio gets 2 over 12, reduces down to 1/6 of this whole circle there. How would I do it in the 1/6? Well, we could think about it like this. 1/6. Well, if I cut it into a third, which would look like this, it'd be half of a third, so you'd get this, about this much here would be good old Ohio. And then half of a 6, because that's half of that. You know, if you put Kentucky and Missouri together, they would form the same as Ohio, so you could cut that like this, Kentucky and Missouri. And then whatever's left here, the 5 million here would be other. So then you can kind of see where the car production portion thing is. Perfect, wonderful, good, we got so much more to do here. Flipping the page there. We've talked about a line plot before, yes? This year? That's where you did this little thing, and they give you all that stuff there. Let's jot that down. What is there, 5, and then 2 8s, 5, 8, 8, 2 10s, and 11. What is that, 4 12s? 12, 12, 12, 12. 2 13s, a 14, and a 16. 2 17s, an 18, and a 19. And if you remember, the whole line plot went like this. I need to mark off from 5 to 19 there, so 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then what do? You put an X above each number where it's represented, 5, 6, 7, 8, 9, this is 10, 11, 12, 13, 14, 15. So 1 X above the 5, 2 X's above the 8, 2 above the 10, 1 above the 11, 4 above 12, 2 13s, 1 14, no 15s, a 16, 2 17s, an 18, and a 19. We did that, right? Yes?
Yes.
Work with me here, kids. Work with me. Okay. Well, with that being said, we also have what we call, believe it or not, they're called measures of central tendency, but we're not going to write that down because we don't use that. We have 4 things we're going to talk about. They are the mean, the median, the mode, and the range. And that's when you're talking about a list of numbers. Does anybody know what the mean means? Abram?
The average.
It is. Mean is the exact same thing as the average. And of course, we could add all these to get numbers together and divide, I suppose. We're smart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 numbers? Is that right? I really don't want to do 18. Did the book do it for us by chance? Do I have 17? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let's see if we can do this math real fast here. 5 plus 8, 13, 21, 31, 41, 52, what's that, 64, 76, 88, oh look, works out nice, there's 100. 126, 140, 156, ooh, 156 and 34, 190, 208, 227 divided by, what did I say, 18? Take my word for it, it's something like that. I don't think it works out evenly until I get that, so. Looks like it ends up being what, close to 12? Let's just say 12 for now, because I don't want to spend forever on average. What is the median? Anybody, median? You see a median in the road, what is it? It's the,
All divided together.
nope, median is the middle number. Now, in order to find the middle number, you have to order them from least to greatest, which it already is. Which means this, if I have this whole group of numbers here, what number would have the same exact numbers smaller than it as it does greater than it? Well, if there were 18 numbers, where's the middle of 18? 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, it's right here. There should be 9 numbers this way, 9 numbers that way. So in this case, because these two are in the middle are the same, the middle number is 12. The mode, ladies and gentlemen, is the number that happens the most. Which number happens the most? And it's easy to see with your line plot because it's the tallest stack up there. Believe it or not, it is 12 again. And then the range is the difference from smallest to biggest. In other words, the highest number I had was 19, the smallest number I have 5. If you subtract those, what's the difference between those two? 14, not 12. 19 minus 5 is 14. So those, you have those in your notes, mode, median, mean, and range. They come up a lot later on in life. Look at page 267. Oh, no, yeah. No, yeah, no, yeah, no, yeah, yep. Look at page 267, you looking at that? One final thing you need to take notes on before we leave here is called a stem and leaf plot. And it is another way to organize numbers. And this is how that works. Okay, we have this side over here, which is our stem, and this side over here, which is our leaf. Okay, your leaf is only the last digit of the number. Here, I'm going to take the first couple numbers they give us in the book. If you're looking at problem number 6, it gives us 60, 52, and 49. 60, 52, and 49. All the last digits are the leaf, and all the numbers in front of that last digit are the stem. So this is the way it would look. First of all, I'm going to start. Is there a number less than 40? Are there any 30s? No. 49 would be written like this. 4 here in the stem, and because I'm going to order these from smallest to biggest, I'm going to put the 9 way over here. 49 is 40 with the 9 over there. 52, the 2 is the leaf, so whatever's in front of it is the stem. 52 would look like this because I have to leave room in case I have some zeros and some ones over there. And 60 would be 6, 0 like this. How would I write the next two, which are 51 and 47? Well, 50 is already there, so the 1 would go right there. 47, I've already got my 4 here, so my 7 would come like that. So it's 47, 49, 51, 52, and 60. What else do I have there? 53, 62, 60. 53, 62, 60. 53, 62, and if there's another 60, you have to put another 0 because you need to show that there's two 60s. And then it goes to 57, 56. 57, 56. Oh boy. 58, 56, 63. 58, I say 66. 66, 53. Oh, it was 63. 58, 53. Oh, we can do that. 63, 58, 53 now. How about that? Isn't this exciting? 50, 48, 60. 50, whoops, I should have left a number there. 48, another 60. And then 62 and 53. 62 and 53. So there's my stem and leaf plot. If I asked you what the mode, what would be the mode of all this? What number shows up the most? Parker? No, there's no 3s there. Your choices are 47, 48, 49, 50, 51, 52, 53, 53, 53, 56, 57, 58, 58, 60, 60, 60, 62, 63, 66. Amelia?
53.
53 and
60.
60. They both show up there. It's called bimodal, has two modes. What if I asked you which one was in the middle, the median? How many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What's in the middle of 20? The 10th number over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, it falls right between those two. What's halfway between 56 and 57? Unfortunately, it's 56 and a half. That means, we have to stop there because we got to get to the Christmas party.